So this activity, I'm going to kind of look at for the empirical rule and normal distribution. This is what they call those bell-shaped curves. So we have this curve that kind of takes this look of a bell. A lot of data naturally occurs in this phenomenon of this bell-shaped curve. So when we talk about this normal distribution, it's what's called an empirical rule. This empirical rule is actually the 68, 95, and 99.7%. So what we need to know about this empirical rule is, first off, in the bell-shaped curve, notice how there's this mu. The mu represents the mean. So the mean is going to be in the middle of it. So as you move from the mean, if you move one standard deviation to the right, that's going to be just this much here. If you move one standard deviation to the left, notice you have to subtract the standard deviation, you're going to be here. So notice that the 68%, notice how we have this SD and SD. If you move one to the right and one to the left, altogether, that's going to be 68% of the data is going to be between one standard deviation. If you go two standard deviations from the mean, what they're saying is 95% of the data is going to be under the curve. So if we look at this curve up here, if I kind of use a little bit of a drawing, see if I can do this here. So if I go two standard deviations, if I kind of make this a little bit more solid, okay, there we go. Make this a little more solid. That's two standard deviations. So what that means is under the curve, all this here would be colored in. So 95% of the data would be located there. That's what I mean by that. So if we go 99.7%, if we go three standard deviations from the mean, what they're saying there is that I'd actually have to color in all of this. Okay. So a lot of times it's cool to kind of draw this on your paper, and you can kind of shade in what they're describing in the question. Okay. Something else to pick up on as we move on to this. The bell-shaped curve also can be broken up. Notice how the 68% can be divided in half. 34% is to the right of the mean, 34% is to the left of the mean. So 68% altogether would be one standard deviation, but those percentages can be broken up in these fashions. So notice how we have this 13.5% is between one and two standard deviations to the left, and 13.5% data is between one and two standard deviations to the right. So there's all kinds of ways to break this data. So it's hard to ask all the questions there is when it comes to these types of questions. So I'm going to pick out two questions over here. The mean speed of a sample of vehicles along a stretch of highway is 67 miles per hour with a standard deviation of 4 miles per hour. Estimate the percent of vehicles whose speeds are between 63 miles per hour and 71 miles per hour. Again, they're assuming that this data is bell-shaped curve or a bell-shaped distribution. We also call that a normal distribution. So I'm going to just use this bell-shaped curve here that I've already kind of sketched out, or actually copy and paste. So notice how we have this mean, the mu represents the mean here, and they said that was 67. So it's a good idea to draw that or make you a bell-shaped curve, and you kind of add this data to it. Also, it says there's a standard deviation of 4 miles per hour. So if I move one to the right, one standard deviation to the right, if I add 4 to the 67, that becomes the 71. So if I move one standard deviation to the right at 67, that's going to be 71 miles per hour. If I move 72 standard deviations, add 4 again, that's going to be 75 miles per hour. If I add 4 again, that's going to be 79 miles per hour. Now, if I go left of the mean, if I subtract 4, that's going to be 63 miles per hour. Subtract 4 again, it's going to be 59 miles per hour. And subtract 4 again would be 55 miles per hour. If I double check my math, 55 plus 4 is 59. 59 plus 4 is 63, 67, 71, 75, 79. So I don't do a whole lot of math myself without a calculator. So adding's not as big a deal, but subtraction sometimes can mess with me. So anyway, what we're asked to do is estimate the percent of vehicles whose speeds are between 63 and 71. So notice how we have this 63 here, and we have this 71 here. Well, they want to know is what the percentage is that's in between here. And also notice that we only want one standard deviation from the mean. If we're one standard deviation from the mean, that's at 68% we have down here. So we can just use the empirical rule and say that that's 68%. Okay, see if we make this all work here. Kind of going back and forth between two of these here. So that's where the empirical rule is. It's either going to be the 67, 95, or 99.7%. Those are the numbers involved in the empirical rule. So let's go ahead and erase this and see if we can answer one more question here. So the next one says the mean monthly utility bill for a sample of households in a city is $70 with a standard deviation of $8. Between what two values do about 95% of the data lie? Assume again the data has a bell-shaped distribution. So again, we're talking about this type of graph here. So notice how again they said the mean was 70. But this time they said the standard deviation was this 8. Oops. So there's this 8 here. So if I come over here, we kind of see that we have to add 8 to the 70. So it's going to be like 78. Going back and forth here. See if we can get this to work. So now this, come on now, you can do it. So I have a 78. I don't know what that color though. 86 and 94. That would be the adding the 8 to the standard deviation. So that would be right at the mean. One standard deviation would be the 78. Two standard deviations would be 86, and the 94 would be three standard deviations. That would be right here. So then if I subtract 8, that's going to give me this 62, 54, and then 46. So 46 plus 8 would be 54. 54 plus 8 is 62. 62 plus 8 is 70. That looks okay. So what they're talking about is 95%. Between what two values do 95% of the data lie? Notice that this 95% applies to two standard deviations. So if I go two standard deviations, that would be here, and two standard deviations would be here. So what they're saying is 95% of the data is going to be in this area here. But all they're asking for is what are the values that we're talking about. So 54 would be the low end, and the 86 would be the high end. So we're between 54 and 86 would be the two values that we're between. So that's how we can use an empirical rule and the bell-shaped curve to answer a few questions about statistics.